B-21 Raider is being built to enter airspace designed to destroy aircraft like it. Far from home, it could face overlapping radar networks, fighter patrols, and long-range surface-to-air missiles, all protecting targets considered beyond the reach of conventional bombers. The Raider would not rely on extreme speed or heavy armor. It would survive by making itself difficult to detect, track, and engage long enough to complete its mission. But stealth is only part of the story. The B-21 is also designed to share information, receive new capabilities, and adapt as enemy defenses evolve. To understand why America needs such an aircraft, we must first examine the limitations of the bombers it will replace. The B-52 remains an effective long-range weapons carrier, but it was not designed to penetrate modern air defense networks. In a high-threat conflict, it would normally launch standoff weapons from outside the most dangerous airspace. The B-1B provides speed and a large conventional payload, yet decades of demanding operations have placed increasing pressure on its aging fleet. Only the B-2 Spirit was built specifically for penetrating stealth missions, but just 21 were produced, and its small fleet requires extensive maintenance to remain operational. Meanwhile, potential adversaries have introduced mobile radars, networked missile batteries, advanced fighters, and sensors intended to challenge stealth aircraft. The Air Force therefore needed a bomber that could reach distant, heavily protected targets without depending entirely on standoff weapons. It also had to be easier to maintain, available in greater numbers, and adaptable enough to confront defenses that would continue evolving for decades. Meeting those requirements would demand more than an upgraded B-2. It led to one of the most secretive military aircraft programs of the modern era. That program was publicly known as the Long-Range Strike Bomber. In October 2015, the U.S. Air Force selected Northrop Grumman to develop it, while its performance, internal systems, and contract value remained largely classified. A year later, the aircraft received the designation B-21, marking it as the first new American bomber of the 21st century. The name Raider honored the Doolittle Raiders, whose 16 B-25 bombers carried out a surprise attack on Japan in April 1942. For years, the public saw only carefully controlled concept images. The first aircraft was finally unveiled at Air Force Plant 42 in Palmdale, California, on December 2, 2022. Even then, public viewing was tightly restricted, revealing little beyond its frontal shape. On November 10, 2023, the B-21 made its first flight and traveled to Edwards Air Force Base for testing. The milestone proved that the secretive bomber could fly, but it revealed almost nothing about how it was intended to survive. The visible design offered only the first clues. The first clues are visible in the Raider's shape. Like the B-2 Spirit, it uses a tailless flying wing configuration, blending the fuselage and wings into one continuous form. This is not simply an aesthetic choice. Vertical tails, exposed engine components, sharp corners, and abrupt changes in angle can reflect radar energy toward a receiver. Removing those features and carefully controlling the aircraft's contours help reduce its radar signature. The B-21 appears smaller and more refined than the B-2, with engine inlets blended into its upper surface and fewer visible breaks across the airframe. Its weapons are carried internally, preserving the smooth external shape. However, its exact dimensions, materials, engine type, performance, and methods for controlling radar and infrared signatures remain classified. Stealth does not make an aircraft invisible. It reduces the distance and reliability at which sensors may detect and track it, giving defenders less time to respond. The B-21 is designed to complicate that process, but its actual effectiveness is unknown outside classified testing. The Air Force calls the Raider a sixth-generation aircraft because its advantage is intended to extend beyond shaping and materials. It combines next-generation low observability with advanced sensors, secure networking, and an open architecture designed to accept future upgrades. Instead of operating as an isolated bomber, it could exchange information with other elements of a wider strike force. That combination of stealth and adaptability may determine whether the Raider remains effective as defenses evolve. But during a long-range mission, these systems still have to be managed by the two people inside the cockpit. Those two people will operate inside a cockpit that remains almost entirely hidden from public view. Its displays, controls, and mission systems have not been officially revealed. However, in July 2026, the U.S. Air Force confirmed that the B-21 will operate with two pilots, reflecting the demands of extended long-range missions. A Raider sortie could involve many hours in the air, aerial refueling, secure communications, and constant monitoring of the aircraft and surrounding threats. Automation may reduce routine workload, but it cannot replace human judgment when conditions change or critical decisions must be made. Two pilots also make it easier to manage fatigue during exceptionally long flights. Yet, operating the aircraft is only part of their responsibility. The mission ultimately depends on what the B-21 carries and how those weapons are delivered. Those weapons will support two very different responsibilities. The B-21 is being developed as a dual-capable bomber, able to conduct conventional strikes and contribute to America's nuclear deterrent. Its exact payload and complete weapons configuration remain classified, but the Air Force confirms that it is designed to carry both direct attack and standoff munitions. Direct attack weapons would require the Raider to penetrate closer to a target, placing greater demands on stealth and mission planning. Standoff weapons could be released from much farther away, reducing exposure to the most dangerous defenses. The crew could therefore select an approach based on the target, the threat, and the wider objective. The B-21 is also intended to operate as part of a larger network involving intelligence, communications, surveillance, and electronic attack. Updated information from other platforms could help the crew respond when a target moves or defenses change. Its nuclear role is primarily about deterrence, convincing an adversary that even heavily protected targets remain at risk. But these capabilities are still being tested. To see how they might work together, the Raider must be followed through a representative mission, from planning and takeoff to penetration and return. Such a mission would begin long before takeoff. Intelligence teams would identify the target, map surrounding radar and missile coverage, and monitor changes in enemy activity. Planners would then select the route, timing, fuel requirements, and weapons. A fixed command facility might allow careful preparation, while a mobile missile launcher could change position after the Raider was already airborne. Before departure, technicians would inspect the aircraft's systems and low observable surfaces. The two pilots would review the latest intelligence and begin a flight that might continue for many hours. After takeoff, the B-21 could meet an aerial tanker outside hostile airspace. The Air Force has already demonstrated in-flight refueling with a KC-135, confirming a capability essential for missions across intercontinental distances. The tanker would remain away from the most dangerous defenses, leaving the Raider to continue toward the target. The threat picture could change during the approach. Radars might relocate, fighters could launch, or the target itself could move. Information received from satellites, command centers, or other platforms could allow the crew to adjust the route and attack plan. Depending on the situation, the Raider might release a standoff weapon from a distance or penetrate farther to deliver a direct attack. After striking, it would exit the defended area, possibly refuel again, and return to base. Yet the mission would not end when its engines stopped. Technicians would analyze system data, inspect the aircraft, restore its low observable surfaces, and prepare it for another sortie. Whether this process can be completed quickly enough to sustain repeated missions depends on one of the Raider's least visible innovations: the digital system behind its design and maintenance. That digital system began shaping the B-21 before the first aircraft was assembled. Engineers used computer models to design components, test how systems would interact, and identify manufacturing problems before they reached the production line. The resulting digital ecosystem is intended to support the Raider throughout development, testing, upgrades, and maintenance. The first flight test aircraft was not a simplified prototype. It was built with production representative tooling, processes, and mission systems, allowing engineers to collect more relevant data, while factory teams gained experience assembling the operational design. The Raider's open architecture should also make future upgrades easier. New sensors, software, and weapons could be integrated without redesigning the entire aircraft, helping it adapt as threats change. Digital tools are also intended to reduce maintenance demands. Preserving the B-2's low observable surfaces requires specialized materials, facilities, and extensive technician effort. The B-21 uses newer processes designed to be more durable and easier to repair, potentially allowing more aircraft to remain mission-ready. However, that advantage has not yet been proven through sustained operations. Before the Raider can demonstrate its reliability, it must complete an expanding test campaign while production advances at the same time. That parallel effort is already underway. The first B-21 reached Edwards Air Force Base after its maiden flight in November 2023, joining a combined team of Air Force and Northrop Grumman personnel. A second Raider entered flight testing in September 2025, allowing engineers to gather data from more than one aircraft. The campaign evaluates far more than basic flight performance. It includes mission systems, software, communications, weapons integration, and the durability of the aircraft's low observable surfaces. In 2026, the Air Force also released images of a B-21 receiving fuel from a KC-135, validating an essential capability for long-range operations. Production is progressing at Air Force Plant 42 in Palmdale, California. The Air Force has increased planned annual production capacity by 25% and intends to acquire at least 100 Raiders. The first aircraft is expected on the ramp at Ellsworth Air Force Base in 2027, with Whiteman and Deadliest planned as additional operating locations. The B-21 will gradually replace the B-1B and B-2 while serving alongside the modernized B-52. Yet progress in testing and production cannot answer the most important question. How difficult will the Raider be to detect once advanced radar networks begin searching for it? It may be detected, but detection alone is not enough to stop it. An air defense network must first notice a return, determine that it represents an aircraft, establish its position, and maintain an accurate track. Only then can it provide a fighter or missile with information precise enough for an interception. A faint or occasional return in a broad area is very different from a weapons-quality firing solution. Lower frequency radars may indicate the general presence of a stealth aircraft because their longer wavelengths interact differently with its shape. However, they often lack the accuracy needed to guide a weapon independently. Higher frequency radars provide greater precision, but the B-21's shaping and materials are intended to reduce the distance at which they can track it effectively. Modern defenses attempt to overcome these limitations by combining multiple radar bands with passive sensors, infrared detection, airborne platforms, and data analysis. The Raider is designed to confront this entire network through low observability, careful route planning, controlled emissions, and coordination with other forces. Even so, its actual signature and defensive systems remain classified, and it has never faced combat conditions. The decisive question is whether an adversary could turn a detection into a firing solution before the B-21 completed its mission. But radar is only one danger. Some of the Raider's greatest vulnerabilities may exist far from enemy airspace. Those vulnerabilities begin on the ground. Before the B-21 can approach defended airspace, it needs a secure runway, fuel, maintenance, and support from a much larger network. In a major conflict, bomber bases could be attacked by ballistic or cruise missiles, forcing raiders to disperse to locations with fewer specialized facilities. Tankers create another pressure point. They extend the bomber's reach, but aircraft, such as the KC-135, are easier to detect and cannot follow the raider into heavily defended territory. An adversary might therefore target the tankers, satellites, communications, and command systems supporting the mission, rather than concentrate only on finding the bomber. Software and networking create additional cyber and electronic warfare risks. Open architecture enables faster upgrades, but every new connection must also be protected. Finally, capability depends on numbers. Building, maintaining, and defending a fleet of at least 100 raiders will require sustained funding for decades. Until operational squadrons demonstrate consistent readiness, the B-21's reliability and availability remain unproven. Its potential is clear, but the final question remains: is the Raider truly revolutionary or a more practical evolution of the B-2? The answer is both. The B-21's flying wing shape is an evolution of the B-2, but its ambition is far greater: to make penetrating stealth more connected, adaptable, maintainable, and available in larger numbers. If it succeeds, the Raider could remain effective even as the defense is built to stop it continue evolving. Yet, its decisive capabilities remain classified, and its greatest promises have not been proven through sustained operational service. Success will depend not only on avoiding radar, but on production, readiness, secure support networks, and the speed of future upgrades. Is the B-21 the future of air power, or an expensive promise still awaiting its real test? Share your verdict below and subscribe for more documentaries on the aircraft shaping modern warfare.